Okay, today we're going to talk about ordering rational numbers, okay? Ordering rational numbers. So that's exactly what it means. We're going to put numbers in order. So sometimes the order might be large to small, sometimes the order might be small to large. So we have to read carefully to determine that. So anytime we're putting numbers in order, we want them all to look the same. And because we have lots of different types of numbers in the 6th grade, right? We have percents, we have decimals, we have fractions, we have all kinds of different numbers. Because we have so many different numbers, we have to come up with the same format. So anytime we're ordering numbers, we are going to put them into a decimal form, okay, first. Okay, so all numbers must be converted. All numbers must be converted to decimals before we try to place them in order. And specifically, we want decimals that look like money. So we're going to go to 2 decimal places when it comes to our decimals, because we know money, we've used money, we've spent money, and we know how to order that from least to greatest, okay? So all numbers, we want them to look like decimals. So in order for them to be converted to decimals, which we've already learned how to do using DFP, we are going to, if it is a percent, we will take that percent and we'll grab the decimal and we're going to double hop twice, and now it is a decimal. Okay? If it's a fraction, we're going to label our cowboy and horse and then boots, hat, donut, donut, and we're going to divide to make our decimal. So again, if you have a percent, you're going to grab the decimal and double hop to make your your decimal. And then if you have a fraction, you're going to cowboy and horse divide to make your decimal. Okay? So we're using that same DFP, what we already learned, we're just applying it to a new problem type. So open these up and let's talk through some examples. So example number 1, Dana placed the following points on a number line, okay? So we have point P, which is negative 24 over 3. We have point Q, which is negative 9 over 2. We have point R, which is 7 over 2. And we have point S, which is 15 over 3. If you notice, every single one of my fractions has a very large cowboy and a very small horse. And we know we don't leave fractions like that, so we need to cowboy and horse each of these fractions and make sure that we come up with a decimal to compare, okay? So the very first one, you'll notice it has a negative sign in the front, negative 24 over 3. Well, whatever my answer is still going to be negative, because even if I divide it, it's still going to come out and be a negative number, okay? So I'm going to label C, my cowboy, and put 24 in my house. So I'm going to come over here, put 24 in my house, boots and hat. I'm going to put 3 outside, and I'm going to set the table, okay? So can 3 go into 2? No, but it can go into 24 8 times, because 8 times 3 is 24. So I get 0. And so I know that 24 over 3 is actually just 8. And remember, it was negative before, so it's going to stay negative because dividing didn't make it positive. It stays negative. So basically, is point P at negative 8? Well, let's find. We have negative 1, negative 2, negative 3. Notice we're counting backwards. Negative 4, negative 5, negative 6, negative 7. Oh, yep, there's point P, and it is correct at negative 8. But remember, the question says which point is not correctly placed on this number line, okay? So let's try the next one. The next one says point Q is at negative 9 over 2. So again, if the fraction was negative, then my decimal is also going to be negative. So I'm going to come over here and I'm going to divide. 9 is my cowboy, so I label it. I'm going to put 9 in the house, boots and hat and a donut, and I'm going to put 2 outside, set my table, and I ask myself, can 2 people sit in 9 chairs? Yes, 2, 4, 6, 8. So 4 times. So I'm going to put my 4 in the first spot, and then I have my decimal. And 4 times 2 is 8. And when I subtract, I have 1 left over. Because I have 1 left over, I can't stop, and so I need that donut. So can 2 people sit in 10 chairs? Yes. 2, 4, 6, 8, 10. So that's 5 times. So I fill in my blank and I end up with 0. So this number will be 4.5. So I have negative because it was negative before. And this time it's 4.5 or 450. Remember, we like it to look like money. So because this is a decimal, I made it look like $4.50. So again, I'm just going to start at 0. And because it's negative, I'm going to count backwards. So I have -1, -2, -3, -4, and then 450 would be just a little bit more than 4. So point Q should actually be here, because right now it's between 3 and 4, which is 350. But we know 450 is between $4 and $5. So point Q is in the wrong spot. So which Q is incorrect? I mean, which number is incorrect? Which point is incorrect? That would be point Q is not in the correct spot. And that's kind of how we look at it. So positives count forward and negatives count backward. All right. And so we could keep going and double check these, but just for the purposes of the time for the notes, I'm going to move on. So example number 2, the table shows the portion of a day 4 students used to build a website. So Alondra used 29.4% of her day. So see how it has a percent sign? That means we need to change it into a decimal so that we can compare all of our numbers using the same format. So it says list our numbers from greatest to the least, okay? So I'm going to go ahead and write that. I want greatest, and then I want to go all the way to the least. And I go ahead and rewrite it down just to remind myself so I don't forget. So I know I'm going to start with the biggest number and I'm going to end with the smallest number. All right, so again, even though this has a decimal, it's not a decimal yet because it has a percent sign. So how do we move from a percent to a decimal? Well, I'm going to grab my decimal point and I'm going to hop once, twice to the left, 2 hops to the left. So that's exactly what I'm going to do. I'm going to grab my decimal point, hop once, now it's in between 2 and 9, hop twice, now it is in the front. So as a decimal, this is actually going to be 0.294. And because we want it to look like money, we're actually going to get rid of the 4 because money only has 2 decimal places. So we're going to pretend that this is 29 cents. 29 cents, okay? So now we are going to do the same thing for Jordan. Jordan used 37.6%, okay? And we know that even though it has a decimal, it's still a percent. We have to turn it into a decimal using our double hops. So I'm going to grab my pen. I'm going to grab the decimal point. I'm going to hop once, twice, 1 hop per number. And now it's in the front. So I have 0.376 because it was in front of the 3. And again, I do want this to look like money. And so I'm actually just going to, if you want to round, you can say 5 or more, raise the score. 4 or less, let it rest. And so this is 5 or more. So we could turn this into 38 cents. Or you can just say this is 37 cents. So I know that the 6 would really make that 7 a 38. But for the purposes of this problem, it's not going to be close. So we can leave it 37 cents. Okay, just like the 4, we would leave the 9 alone because the 4 is under 5. Okay, and then these 2 are fractions, and we know what do we do with a fraction every single time? Well, we label our cowboy. And we know that with small cowboys, our number is going to start with a 0. So I'm going to go ahead and write 0 decimal, and then whatever I get when I divide will go after that decimal. Same thing here. I have a small cowboy. Anytime you have a small cowboy, your answer is going to start with 0 and then your decimal. Hopefully at this point we have 1/4 memorized and we know that it is 25 cents. But if you didn't know that 1/4 was 25 cents, again, you could cowboy and horse divide. 7/25 is probably not something we have memorized. So I'm going to come over to here. I'm going to put my cowboy in the house. boots and hat, set one table for the 7. And then 25 is gonna go outside, and I'm probably gonna need some donuts. So I'll go ahead and set the table for those donuts. All right, so if we count by 25s, I always like to think of it like quarters. So I have 1 quarter, 50 cents, 75 cents, $1, $1.25, $1.50, $1.75, and so on. Okay, so can 25 people sit in 7 chairs? No. But 25 people can sit in 70 chairs, which would be right here on my list. So how many numbers are above it? 2. And we said that was 50. And we subtract and we have 20 left over. I'm going to bring down another donut. I got to keep counting. And then I get to 200. So I have 1, 2, 3, 4, 5, 6, 7, 8 times. 8 times 25 is exactly 200. And I zero out, and I am behind my decimal. So this decimal will be 28 cents. So again, we had 29 cents, 37 cents, 28 cents, and 25 cents. And that makes it so much easier to compare the biggest to the smallest, because now we know what all of those are. We know the money. We've bought things before. We know which one is the biggest amount of money, okay? So we're gonna stack them just to organize ourselves. So I'm gonna grab my pen and I'm gonna just stack them down here. So I have 0.29, I have 0.37, I have 0.28, and I have 0.25. And so I'm just gonna start looking and comparing from the beginning. Well, they're all start with 0, so that doesn't really matter. And so which of these is the biggest? We have 2, 3, 2, 2. So I'm going to use the 3. So the 37, Jordan, is the greatest. So I'm going to put a J for Jordan. And we put that one was first. Okay? First. All right. And then the next biggest would be 29 cents, right? Because we're now comparing the last number. So 9 is the biggest. So the 9 went to Alondra. So I'm going to put an A for Alondra. And then the next one would be 28 cents. And so that's going to be Daniel. So I'm going to put a D for Daniel. And then the last one, the smallest amount of time, was Joshua. So I'm going to put a J-O for Joshua. Just so, oops, I guess I should put a J-O-S. Because Jordan and Josh both start with J-O. So this is Jordan up here, and then Joshua, I'll end it with Josh. All right, and that is our order from greatest to least. All right. And then the next one is all negatives and positives, so no decimals. So we don't have to do any dividing. But what we should do is think about it like a number line. So when you're dealing with negatives, the easiest thing to do is to think of this basic number line. So remember, we always have 0 in the middle, and then we have our smallest on the left and our biggest on the right. And remember, we just count away from 0. So away. All right, so I am going to draw a number line. I'm going to show you both a vertical number line and a horizontal number line, okay? So our first number line will be horizontal, so that means it runs left to right. Remember, 0 is in the middle, and then we have negatives on the left and positives on the right, and we just count away, okay? And then we also have a vertical number line that you can use, which I like to use anytime there's temperature, which these are temperatures. So I'm going to put 0 in the middle. The hotter it gets, the more positive our temperature, and the colder it gets, the more negative our temperature, okay? And so we can just plot our numbers. So we have to think about where would it wants coldest first. So if I want a cold temperature first, am I going to start in the negatives or the positives? Well, the negatives are the cold temperatures, and the positives are the hot. And again, if you wanted to do it horizontally, the negatives are the cold and the positives are the hot, which means if we're starting with coldest, we need a negative. Specifically, we need the negative that is farthest away from 0 on the left. We want as far left as possible. Well, remember we count backwards. So we have 0, -5, 8, and -10. Well, -5 would be here, right? 0, then we count 1, 2, 3, 4, and then 5. Those are all negative. And then we just keep going 6, 7, 8, 9, 10. So we count away from 0. And then same thing on this side. The +8 would be over here. 1, 2, 3, 4, 5, 6, 7, 8. So there's my +8 on this side. Okay. And then remember 0 is in the middle. So I guess I go 6, 7, 8, 9, and then there's 10. And again, if you wanted to do it vertically, remember that the -10 is furthest. We have -5 in the middle because I'm counting away. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Again, those are negatives. And then positives, 1, 2, 3, 4, 5, 6, 7, 8. And that's +8 because it's hot. All right. So which one is the coldest? Well, remember the one furthest away, the one to the left, is going to be our -10. So B and D are automatically out because they do not start with our -10. All right, well then we have 8. So am I going to skip all the way over here to +8? No, because that's going to be my warmest temperature. So it should be last because it's the hottest, right? And so in this case, this one cannot be next because we still have negatives we have to look at. So we have our -5, then our 0, and then our 8. So we have -10, -5, 0, and 8 is our hottest. Again, that is coldest to warmest. So C is our best option, and A is out. So remember, anytime you're dealing with negatives, throw yourself a number line on your paper and just work left to right or right to left, depending on do they want cold or warm. And then number 4. So number 4, again, gives us a mixture of all of these different types of like we have decimal, we have fraction, we have percent, and we have another fraction. And again, they want us to order them. It even says the word order, and it specifically wants least to greatest, okay? Least to greatest. And so again, I'm going to write that just to remind myself, least to greatest, okay? So we're going to turn everything into a decimal that looks like money, okay? Looks like money. So specifically this first one, it almost looks like money. It's already a decimal. In order to make it look like money, I need to throw a 0 on the end. And now it is 40 cents, okay? 40 cents. All right, this one has a big cowboy and a small horse. So I know I need to divide. So I'm going to come over here and I'm going to say, okay, 45 is my cowboy, boots and hat. 40 is my horse. And now I'm ready to divide. So can 40 people sit in 4 chairs? No, but they can sit in 45 once. I subtract and I have 5 left over. I'm going to eat a donut and bring it down. Can 40 people sit in 50 chairs? Yes, once. Again, I'm going to subtract. I have 10 left over. I'm going to eat a donut, bring it down. Can 40 people sit in 100 chairs? Yes, twice. And again, that's going to be 80. And I'm going to have 20 left over. And one more time. Bring down the 0. Can 40 people sit in 200 chairs? Yes, 5 times. And we end up with our 0. So our decimal is 1.125. And remember, we do want it to look like money. So I am going to say, okay, that would be 5 or more, raise the score. So this would be like $1.13. For the problem, I'm just going to cross it out and leave it $1.12. Okay. So for this problem, I am just going to cross it out and leave it $1.12. But if I was rounding, it would be $1.13. All right. And then this is 100%. And we know that we can't leave it a percent, so we need to grab our decimal point and 1-2 hop, just like we did over here. So I'm gonna grab the decimal point, well, it's invisible at the back, and I'm gonna hop once, twice, and it ends up being just $1. Okay, so that one is like $1. And then my last one, Jose, is 2/3. So I am going to label my cowboy and divide. So again, 2/3 has a small cowboy, so I know it's gonna start with a 0. So I'm gonna put 2 in the house, boots and hat, 3 goes inside. 3 people cannot sit in 2 chairs, but they can sit in 20 chairs 6 times. So that's gonna be 18, 2 left over. Bring down your 0. It's gonna be 6 again, 18 again, 2 left over. And what's gonna happen is this is actually gonna just keep repeating and be 6 forever. So I'm just gonna leave it 66 cents. All right, so now that everything looks like money, I can put it from the least amount of money to the greatest. So of my 4 numbers, which one is the least, which one's the greatest? Well, we can stack them like we did over here. So I'm gonna start with my 40 cents, 0.40. And then I have $1.12. And then I have just $1. And then I have 66 cents. So stacking them just kind of helps me line up my numbers. So we know these 2 are going to be our biggest because they start with $1. Specifically, $1.12 is going to be bigger than just a regular dollar. So this one's going to be number 1 and it's going to be biggest. And so that will actually, for my list, will go last. So I know that Lizbeth is my last answer, and 4540, the only one that has her last, would be this one right here. So I'm pretty sure my answer is C, okay? Just to double check, let's pick which one's smallest, which one's the least. So well, which one was the smallest? Well, 40 cents is gonna be my smallest number. And so 40 cents was Eddie. So Eddie is actually gonna go first. So does that work? Yes. You can see the 40 was the first one here and here, but not here or here, okay? And then in the middle, you would have 66 cents is your second number, so Jose. And then we have our $1, which is Elani. And so we have Eddie, Jose, Elani, and then Lizbeth, which is gonna actually match C, just like we thought. But again, picking your least and your greatest is a good way to check these lists. All right, and that is comparing and ordering. Remember, everything needs to become a decimal. Every decimal needs to look like money with 2 decimal places. All right, comparing and ordering.